Hi, this is Margo. This is Sunday evening, early evening, September the 5th, 2021. And man, what a week it's been. I hope everyone is safe and doing as well as possible. Probably some of you were caught in the storm of Ida, and I'm praying for all of you, hoping you're doing okay. But it's another week gone by, and here we are. I'd like to welcome everyone to my show today. This will be my weekly update that I will be putting on YouTube, and we're going to go over sea ice and methane and general climate things, but I'm going to start off with an article that's going to set the tone for what we're going to be looking at on the methane. And this kind of supports my theory of what I've been talking about for the last 3 years about the radioactive stuff, dumps, the stuff that's been dumped in the Arctic Ocean around Novaya Zemlya during the Cold War. So here's an article that just came out this week from the Barents Observer, and let's see, let's get the date. So it was September the 2nd, and the title says, Expedition finds reactors 56 years after dumping. That's exactly what I've been saying. And the subline says, a Russian research expedition has rediscovered the location of the container of 2 damaged reactors from the Soviet Navy submarine K-19 dumped in Ambrosimova Bay in 1965. And this is just the beginning of what they're going to find. And here under the picture it says, currently in the Ambrosimova Bay on the east coast of Novaya Zemlya, the Academic M. Keldysh is a Russian research vessel carrying submersibles and sonars. Screenshot exact Earth ship view. So here's Novaya Zemlya. That's the bottom, the southern island, and these red dots are supposed nuclear dumps where they found nuclear stuff. Here's a picture of the ship that's searching all of this out. Surface ship research vessel. And so we're going to go over this article. And it says, having the exact coordinates for the dumped container with the reactors from K-19 is undoubtedly good news, says nuclear safety expert Andrei Zolotkov with ANO Bologna Murmansk. Zolotkov hopes for risk assessments to be carried out soon, with the aim to see how the reactors could be lifted out of the maritime environment and brought to a yard for safe decommissioning. And then Zolotkov starts talking and says, risks of lifting the reactors can only be discussed after obtaining additional data like seawater samples and radiation examination of the container and its technical condition. He underlines that more than 50 years had passed since the dumping. News agency RIA Novosti was first to report about the research expedition's findings in the so-called White Book on Dumped Nuclear Objects, originally published by President Boris Yeltsin's environmental advisor Alexei Jablokov. The dumping of the submarine's 2 reactors is listed for the Ambrosima Ambrosimova Bay on the east coast of the Kara Sea, but exact location hasn't been confirmed. It was this week the crew on Academic M. Keldysh, with the help of sonars and submersibles, found the container. Both marine researchers, oceanology experts from Russia's Academy of Science, and representatives of the Ministry of Emergency Situations are working together in the expedition team. Now they're going to talk about radiation poisoning. K-19 is one of the most infamous nuclear-powered submarines sailing for the Soviet Navy's Northern Fleet. In July 1961, the reactor lost coolant after a leak in a pipe regulating the pressure to the primary cooling circuit. The reactor water started boiling, causing overheating and fire. Crew members managed to extinguish the fire, but had big problems fixing the leak in an effort to save the submarine from exploding. Many of them were exposed to high doses of radioactivity before being evacuated to a nearby diesel submarine sailing in the same area of the North Atlantic. 8 of the crew members who had worked on the leak died of radiation poisoning within a matter of days. The submarine was towed to the Scofield Shipyard No. 10 in Polyarny. Later, the reactor component was cut out and a new installed. The 2 damaged reactors, still with spent nuclear fuel, were taken north to the Kara Sea and dumped. Keeping the heavily contaminated reactors at the shipyard was at the time not considered an option. Lifting plans. Andrei Zolotkov hopes for the reactors to be recovered, and here's a picture of him. Now, as Russia holds the chair of the Arctic Council, expeditions like this bring us closer to the topic of raising the potentially most dangerous nuclear objects from northern waters, he says. This spring, Russia's foreign ministry invited international experts from the other Arctic nations to a conference on how to recover sunken radioactive and hazardous objects dumped by the Soviet Union on the seafloor east of Novaya Zemlya. Moscow chairs the Arctic Council for the 2021 to 2023 period. 17,000 radioactive objects. I don't know why this wasn't the headline, but it's not just along this east side of Novaya Zemlya. As you can see, it's way out here, down by Svalbard, and probably, I wouldn't doubt if they're all around. Here's one off the coast of Murmansk. Now this area up here in this picture is Severnaya Zemlya. Right at the bottom of Severnaya Zemlya is Komsomolets, where we've been seeing the methane billowing for a year and 8 months now. And I've been saying I didn't know what it was from. No one's talking about it. My gut feeling is it's some kind of nuclear thing that got dumped during the Cold War and is eaten through the seafloor and is, heated up and eaten through, and we've got methane coming up. Anyway, this should have been the headline. The 2 reactors from the K-19 submarine were not the only objects posing a risk to marine environment. In fact, no other places in the world's oceans have more radioactive and nuclear waste than the Kara Sea. And I've shared articles like that before too. right? This whole area is the most radioactive body of water on the planet. And then they go on. Reactors from K11 and K140, plus the entire submarine of K27 and spent uranium fuel from one of the old reactors of the Lennon icebreaker are also dumped in the same sea. So there you go. That's just what they're telling us, so it's probably a lot more than that. That's just what they're revealing. While mentality in Soviet times was out of sight, out of mind, the Kara Sea seemed logical. Ice covered most of the year and no commercial activities. That is changing now with rapidly retreating sea ice, drilling for oil and gas, and increased shipping. The submarine reactors dumped in shallow bays east of the closed-off military archipelago of Novaya Zemlya were all brought north for a good reason. They had experienced accidents and posed a radiation threat at the Navy yards where people were working. Additional to the reactors, about 17,000 objects were dumped in the Kara Sea in the period from the late 1960s to the early 1990s. So over 30 years. About 30 years. I'm thinking it was more than that. Dumping the reactors in shallow waters, someplace at only 50 meters, meant they could be lifted one day when technology allowed. So that's how they're spinning this, that they dumped it in the shallow waters so that someday in the future, when they had the technology, they could lift it out. I'm not buying that. I just think they were just frantic to get it out of sight and thinking, well, we'll just dump it in the cold water and nobody will ever know. And now now that the ice is melting and they're trying to open up shipping routes, right here is the Yamal Peninsula, and right down here is liquid natural gas place on the Yamal Peninsula, and they're shipping in and out. This is the Gulf of Ob. I mean, this is heavily traveled, and this is before they've really opened up all of the shipping routes that they had planned for when the ice melts. There are 3 major shipping routes that are being planned in the Arctic, and I've covered all of this in past shows. But there are many countries involved that are looking forward to the ice-free Arctic, or at least mostly ice-free Arctic, so that they can ship through the Arctic, so that they don't have to go around Africa, the southern tip of Africa, or around the eastern side of the or the western side of the Pacific. So look at this. This is just what they're showing. And here's Franz Josef Land. Here's Svalbard, and so I think I might leave a link in the description box below also for my video I did 3 years ago on Novaya Zemlya. I did a ton of research about the nuclear testing that was done here on Novaya Zemlya during the Cold War, and my premise is that all of this radioactive material that's in the ocean and in the seabed is heating things up, and could be the cause of the rapid heating of the Arctic. That's my premise, because the heating really started in the early 1960s when after a bunch of the nuclear bombs started being tested, and after they started dumping the nuclear waste in the ocean. 17,000 things. Are you kidding me? There's more than that. If they're saying 17,000, it's probably more like 50,000, if they can even count them. So the name of the video is Novaya Zemlya, the smoking gun to rapid Arctic warming, ? And just do a search for that on my YouTube channel. It was really a masterpiece. I really outdid myself on that. And I was never the same after seeing all of that and understanding more about nuclear. And it's I do believe it's from the dark side. Everything nuclear is from the dark side. And so here we go. So now they're being forced to try to clean up not only the Kara Sea, they're going to find other areas. They're going to find this is just the beginning. And once they drag up some of this stuff, and who knows how radioactive it's going to be and how can they transport it. They're going to have robots to go down to the seafloor. This is my theory or my thoughts. They're going to have to make robots to go down to the seafloor and drag it up. They can't send anyone down there. It's all going to have to be remote and by robots. And they may even have to have drone ships that the robots with the cranes load the stuff onto, and then they decide what they're going to do with it. What are they going to do with it once they drag it up? And a whole sunken nuclear submarine. Oh my gosh. So I got excited when I saw that, and I wanted to kind of showcase that. So with that in mind, you'll have a new appreciation for the methane that we're seeing here at CAMS NOAA. Now here is Novaya Zemlya when we're looking at the CAMS picture. And so they're mainly focusing on this east side of, or east coast of Novaya Zemlya and the Kara Sea. But I'm telling you, it was dumped all around, and probably got some of it got moved probably up here in the North Kara Sea. And so here's where we're seeing that billowing, and no one's been talking about it. And if this were part of Russian military waters, this would be why no one's talking about it. So, you know, maybe someday they'll say, oh, we sent the drone research vessel out to CAMS NOAA and we found this thing that had blown up and it was radioactive, and you know, it hit a methane pocket. So there you go. If they ever admit it. I'm not convinced they'll ever admit it. So that's my lead off for the show today. So we're going to go to methane now. I'm tracking the methane data here on NOAA for the 477/469 millibar reading. I've been doing this since about the 1st of March of 2019. Just with this level. Just for my, you know, to see kind of what's happening with methane, because really no one else is going through and tracking it on a detailed basis. They say methane is so dangerous and you know, we could have a blowout anytime, and I thought, well, you know, let's track this. So this is the MET-OP-1 that's been renamed to the MET-OP-B satellite for the morning of the 4th. The mean or average was 1931 parts per billion. The high reading was 2394. So this pink color is the highest in this range, which is anywhere between 2,000 parts per billion and whatever this high number here is. So in this case, it's between 2,000 and 2394. And this is about halfway up in the atmosphere with this read, the 469 millibar. So see, we've got pinks pretty much all the way across the northern hemisphere, and even down here in the southern hemisphere and around the Antarctic as well. I want you to pay attention to right here. Here's some pinkish color. This is next to the Ross Sea. We're going to see methane popping up. Where is it? Was it here? Anyway, it's popping up in the Antarctic too. Here in the afternoon, the mean was 1929. The high reading was 2349. On the MET-OP-2, aka MET-OP-A satellite, the mean was 1909. The high reading was 2330. In the afternoon, the mean was 1908 and the high reading was 2441. Here's the spreadsheet and chart that I've been working off of. So for the 4th, averages out to be 1919.25 parts per billion. That's showing a slight decrease over last week of 0.75. Now last week we had hit 1920, this line, so that was a new high, and then so it's gone down slightly this week. I don't think we're done with the methane rise, and I think we just did a little stair step there. So we're 21 parts per billion higher than this time a year ago. We're 62 parts per billion higher than March the 1st of 2019. And you can see the trends. Here was last summer, and we peaked out twice in September and October. Late September, and then in like mid-October we reached the highest methane, and then it went down during the winter, and then it started back up. Here was so this was 2020. Here was 2019. So it's, look at how high we've cut. See, and when I redid the chart a couple of weeks ago, it skipped, left out the tens, like 1910, 1930, and now the increments are 20s. So I'll show you what it did this week. And I do updates during the week, and I post them on my Subscribestar page. And if you'd like to join us over there, we'd love to have you. It's only $5 a month, and you have exclusive content before the rest of the world gets it, when I finally get around to archiving it on my website. And my YouTube channel is not monetized, and so this is a way you can get exclusive content and be tracking everything, and as soon as it happens, and also a way to support me, and I would appreciate it. So here we are. Oh, another way people can support me is through the PayPal link, and I'd like to thank the person who sent me the donation this week. It's very much appreciated. You know, some months you just have extra expenses or extra things you need to get, and so it's been one of those months. So it's appreciated because, you know, nobody knows how long we're going to have to be here, and you know, it's just good to support people who help you understand the world. So give you food. This is information that if you find useful, it's like eating. And anyway, so that's my pitch. I'm not real good at trying to sell myself. So here we are. Last week in my show for the 25th, we were at 1920, and see it jumped up there, 2 parts per billion there, and then on the 29th it went up to 1920.5, so it went up half a part per billion. On Monday, on Tuesday it went up another half. On Wednesday it went up 0.75. On Thursday, no change. So Wednesday and Thursday we were above that 1920. We were at 1921.75, and we were 23.25 parts per billion higher than a year ago. Then Friday, I'm lost. So this was Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday. Okay, Thursday. So this was Tuesday, Wednesday. Then Thursday, it went down. It was a sharp decrease of 2.25. And then Friday, it went down another 1 part per billion. And then for Saturday, for our show today, it went up 0.75. So that's typical, you know, to do some stair stepping, especially during the week. But we're not done with methane, and we could have that blowout just any moment now. So now we'll look at methane from CAMS. I have Saturday the 4th up, Arctic view, and surface level. And here's our color ledger. So the data is for Saturday, and the forecast period is Sunday through Wednesday. So we'll look here at the Caracees, since we just talked about that. See these waves moving out. So we've got methane. That's these waves moving out from the land, but it's also coming up through the ocean. And when we look at Climate Reanalyzer, the sea surface temperature here is it's red and brown, so this means that it's a lot higher than normal. And also up here in the Laptev Sea, it's in the reds and browns region as well. We're also see this area around Komsomolets. It kind of goes away for a few days in the forecast period, and then Wednesday it's billowing back. So when it goes away, it's a temporary thing. We're seeing lots of high methane in the Scandinavian area. Also Russia. This is the Yakutia area in Russia, where we're seeing the wildfires, and then they kind of spread out. But it's been raining up here in Russia and over this Kara Sea, and anyway, we've had a lot more rain up here in the Arctic recently, and that's because of the warmer temperatures as well. And I think the higher methane, and we can see the green, see these waves moving out. So anyway, we've got methane filling up in Alaska. We've got lots of high readings throughout Canada. Okay, now we'll go to the North Pole view. "17,000 nuclear objects." I can only imagine. I think they just, maybe, if they were lucky, they put them in some kind of plastic bags or containers or something and threw them over. I have no clue. So here we're seeing the northern hemisphere. Look at Europe. Here's France. Here's the UK and Ireland. Here's Germany, and then Italy down here. But that's a big blob. Here's the Persian Gulf. You see it spilling over. Here's India. Here's China. This is Korea. It goes all the way up. Here's southern Russia. And you can see the green, how the green is like the background color, mainly in the northern hemisphere now. Here in the US and Canada, now we're seeing higher readings up here in the northeast. This is after Hurricane Ida dumped. It takes a few days really for the methane to start building up and soaring, because the water gets stagnant, there are sewers backing up, and the water, as they're dealing with it, it's just all really contaminated, and it starts giving off these noxious gases and a lot of methane. Look at Texas. They've had a ton of earthquakes in West Texas this week. I think there's a new fault line opening up there. Now we're going to pop down to the Antarctic. Here's north, south, east, west. Here's the Western Peninsula. You can see it coming up here where the Larsen B ice shelf used to be, and then it migrates down along the Larsen C ice shelf. See right there, popping up on the Larsen C. here it's along the Brunt ice shelf. See the higher readings there. Let's see. We also have the Amory ice sheet right there. See that? That's right at the ice edge. There's some open water there, so it popped up there. Watch, when it starts over, it'll be right there. See? Yeah. And the sun is starting to come up in the Antarctic, and there are areas that are in the sunlight now. Okay, now we'll look at the global view. And I started really looking into the stuff and started doing reports in 2018. So, you know, I haven't been doing this for decades like some people have, but 2018 was my year where I just got really obsessed with following all of this and started doing reports, and that's how I came to do what I'm doing now. So so you can see the higher readings around this east side of Australia, and down here on the southwest side where Perth is. Here's New Zealand down here. Here it's streaming off of South America. See that? And the background color in the southern hemisphere is primarily this light blue, which is a step up from the darker blue. The darker blue is 1800 parts per billion. The next one up is the 1820. And then we've got the next one up, see, coming off of South America and this Central America area. So that would be 1840 creeping out. We've got some green waves, greenish colors waves. So, you know, we've got higher readings coming further south here. Now we'll go to 500 HPA. So this is about halfway up in the atmosphere. So, let's see, we've got reds down here over Africa. Here's the higher readings from India over into China, and then reds up in the northern part. Now we'll look at total column. So here we've got the highest readings at China. Here's India. Persian Gulf is got some high readings around there. Then we've got the reds from Africa all the way across. Now before we go into the sea ice, I just want to go ahead and take you through just a couple more things. Here's sulfur dioxide today. I like to look at that. We've got a new high reading here between Australia and the Antarctic. This is generally, when you see something like this, kind of isolated, is generally from an earthquake or a volcano going off. So this could be a precursor of an earthquake there. We've got high reading here at Kamchatka. And we've had some high readings here in the Philippines this week too. Also, Mount Etna went off this week, so we've been seeing, I'm thinking that's what caused these higher readings that we saw a little bit east of there this week. Here you are at 500 HPA. So this area just south of Australia, it is registering, and it's around that plate line, that Antarctic plate line. So it could just be some plate movement just releasing some sulfur dioxide. Got a high reading here at Kamchatka, then here at the Philippines too. Here's the ozone hole over the Antarctic today. Now yesterday it had kind of connected up in a donut shape with the thinnest around the outside there, but it's morphed again. The whole continent is in the thin zone, but where you see the purple and the colors inside these thick black lines, this denotes into the danger zone below 220 Dobson units. Now this purplish color is between 200 and 220 Dobson units. Then this blue color is 175 to 200. This navy blue is 150 to 175. So we can see that it's getting thinner and it's getting much bigger. And it's cold. The air is very cold down there. The sun is starting to come up, but it's not warming up enough yet for the Earth to be creating its ozone, so the hole is coming back. Here in the Arctic, here's the thin layer of the ozone, starting with the greens, any greenish color, and the blue-green. We can see it's spreading out, and this is from the smoke. The smoke will just eat up the ozone layer. And this is the smoke today. We can see the highest is on the west coast of the U.S. here in North America. But see the grays. There is a lot of smoke just going all the way across the planet from all the different stuff on fire. Here's Africa in the Congo, and here's South America. See, that's not as bad as it has been. That's all of those. Now we'll move on to sea ice. I took these pictures. These are pictures I download every day from Climate Reanalyzer. So we'll just go through what the sea ice and snow cover looked like this week. Here it is today, and this Beaufort Sea is collapsing. And when we look at NASA Worldview, you'll be shocked to see the open water, and you know, this is kind of deceiving where you see some whitish, you think, oh, well, that's pretty good ice. No, there is a hole there. And then this ice to the left of that, or the west of that, is just real not good ice at all. There's a lot of open water, and so it's a little deceptive to look at these models and think, well, there's still good ice up there. Well, you know, maybe, but not much. Not like what it looks like in the pictures. So let's go through. Here was what it looked like last week in our show on Sunday. And we'll just click through. Here's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then today. So it's still losing extent. It's slowed way down as far as the extent, and that's, you know, how far out the ice is. And so when they're figuring the blue ocean event, they measure only extent. They don't care about the quality of the ice, how thick it is, if it's just a little pond scum, just a little skim on the top of the water. They count that as extent. So there's that. So that's why when you see these models and you see, oh, well, there's purple all the way out here, that's pretty good. Well, but there's a lot of whitish in there too. And now I've determined that when you see like the white tinge, that's open water, a lot of open water here. So this is the Navy model for sea ice thickness in the Arctic. This is for today, and we still have our hole above Greenland. See there, and let's see what else. It's thin here in the Lincoln Sea. This nearest strait has opened up. The edge here on this east side is still deteriorating. So here's Komsomolets, here's Severnae Zemlya, here's Novaya Zemlya, so it's a different angle. Here's the Kara Sea. So all that radioactive stuff we're talking about here, and I'm saying all the way up, and probably out west of Novaya Zemlya too. And the picture they showed some down here by Svalbard. So, you know, they might have even carried it in ships and dumped it all over the place whenever they could. I have no clue what they did or when they did it. So, we just know it's got to be there with all the tests that were done above ground, and then they have an underground base up here, and below ground too. And the largest nuclear bomb that's ever been detonated was done off the coast, just above Novaya Zemlya, right up here. So you're going to have nuclear waste when you've got stuff like that. Not to mention the nuclear submarines, you know, that sunk. They couldn't save them. So anyway, so here's some aqua, which is the thicker ice that we're seeing. The bright aqua is about 2 meters thick, and then it goes down from there as it goes into the dark aqua, into the blue, and then the purple, and then the lavender. So we still have a little bit of thicker ice right here, and then So quadrant 1 is just very thin ice, all in quadrant 1. This is the Laptev Sea, it's open. This is this East Siberian Sea, it's mainly open. Then quadrant 2, we just have this aqua here, and then the thin ice here from the North Pole over. Then in quadrant 3, we have the whole above Greenland. We have a little bit of aqua just above Greenland. And then we've got this is the thicker ice that reformed over the winter last year from the thin. It reformed, and this ice, it reforms because the temperatures go down, and also the way the ice drift goes, it pushes the ice. The ice generally flows from the Russia side, or the water generally flows from the Russia side across to the Canadian side. And so that's why you see it piling up over here. So this has been sliding up, and it's still deteriorating, and we can see in these tributaries in this Canadian archipelago, it's still melting. A lot of it is totally ice-free. We've got some aqua through here, not much though. And then here in this Beaufort Sea, this is deceiving. Like I said, a lot of this is just really open water with pieces of ice here and there. And then these little nubs of the dark aqua, this is what's left of the multi-year thicker ice that was left at the end of last year, that migrated down during the winter. We watched it during the winter migrate down into the Beaufort Sea above Alaska, and then it's been melting and coming apart. Now, I really don't think we're going to have what will be considered a blue ocean event this year, simply because we've got so much of this thin ice, and it spreads out. When it melts, it spreads out. So they're not gonna call a blue ocean event. I really don't see it happening this year. So here's the 30-day animation. The data goes back 3 weeks, and the forecast period goes out to the 12th, which is a week from today. Now, generally, the minimum extent is reached in the Arctic around the middle of September. I don't know when it's going to be this year. I'm thinking that it could go a little longer. So it goes out to the 12th, which is almost to the traditional minimum extent time period. Now see this aqua group here? See, in the forecast period it slides away from those islands there and out into the ocean. Once it's away from the island, it'll be tossed around. I'm thinking that'll go away. Okay, here we are at the end of the model. So I'll show you the date just to document it, the 12th there. So this is where they're showing it to be a week from now. So this white really is no ice. So it's melting in. It's still losing extent. That white, see all this white down here. And then here's the thicker. This is what's going to be left of any really thicker ice, and it's not really good. I mean, this is about 1.75. This blue is about 1.25. The purple, the dark purple, is about 1 meter thick. And it's not good put together well. It's coming apart. So with the open water, then the water is absorbing radiation and the sunlight, and then we have a whole latent heat situation set up. So it's going to be much harder for the ocean to refreeze. So that's what we've got there. We still have this hole above Greenland by next week. We've got a big hole here. This is part of the Beaufort Sea, and this is part of this Canadian archipelago. And then this Beaufort Sea, there's a lot of white there. So we'll move on. Here's the Beaufort Sea ice thickness. This is as of yesterday. This is the latest data on the Navy website. See all this white? That's open water telling you there's a lot. So there it is today. And there's not much of this aqua. See, it's just right around the coastline. Here's the 30-day animation where it goes back 3 weeks with the data, and the forecast goes out to 6 days from now, to next Saturday. Watch this hole open up. See? So this pulls away and it's melting at the same time. Right there. It also pulls away from the coastline here. See? And then see, that just goes down to nothing practically. So there's that. Now we'll hop down to the Antarctic. I'm afraid this show is turning out to be quite long because of my shared that article. But I feel like these things are important for you to have a bigger perspective on everything. So here, here's the sea ice thickness for today for the Antarctic. See how thin it is around the coastline. And here at the Ross Sea, there's no ice there next to the ice shelf. Also here around Pine Island Glacier and around Thwaites. See, it's so thin. And here's the 30-day animation. So the data goes back 3 weeks and the forecast is out a week from now. Now, National Snow and Ice Data Center, it shows the extent going down this week. Now, we had been above average all winter down here. It's their winter time. It had been above average, but now it's going down. So, you know, have they reached their maximum extent? I think so. I think they've reached their maximum. We'll see, though. So, from here on out, it may thicken up some, but remember, the sun's coming up, the earth is tilting, and in the northern hemisphere the days are getting longer. You'll notice that. I mean, it's getting dark much earlier than it had been during the summer. I mean, it is September now. Hard to believe. So there's that. Now we'll move on. So here's National Snow and Ice Data Center, Sea Ice Index. This is for the Arctic, and this is concentration. So we can see this matches what we saw on the Navy website. And here's the hole in the Beaufort Sea, and then the dark blue, that means it's not very concentrated, meaning a lot of open water between the ice, and it's quite thin and mushy and maybe slushy if you're lucky, but just a lot of open water. The only ice that's really concentrated at all is along this Canadian archipelago and up a little bit here. Here's their chart for sea ice extent. View image. Okay. And area of ocean with at least 15% of sea ice. Now, they don't call a blue ocean event unless it's 1 square, what is it? 1 million square kilometers. This is measured in millions of square kilometers. Now, this dotted line was 2012. So let's zoom in. Here we are. This year, we're the blue line. And it's still going down, kind of parallel with the average. But we're not way as low as 2012 was. So we're about a little over 5 million square kilometers right now for extent. And remember what I told you about what they count for extent. But it's still going down, as you can see. It's just not going down, not as fast as 2012. Now we'll look at the Antarctic. So here it is, the concentration. And, well, you can see how far out it is. That's the extent. The gold line is the median. And here's their chart for extent. So this is as of yesterday. Here, this blue line is this year. This gray-green line is last year. And see, it took a nosedive this week. Oops. See, in the last couple of days. But it's following the curvature of last year, where it took a little nosedive and then it continued still building for a little while. So we're still higher than last year, but not much. There's that. Now I'm going to show you Greenland. Here, they're not showing very much melting today. Just a tiny bit of the salmon color. Now earlier this week we were seeing quite a bit down here in the southern part because there'd been a lot of rain. Here are the cumulative melt days since January 1st, and see, just a little bit of the interior has not had any melting. See, the solid white. So this is kind of unprecedented that so much melting has occurred on Greenland this year. And look at the cumulative days here on the west side. It's going up into this dark red, like 90. Now here's their chart, melt extent. So this blue dotted line is the median. The red line is this year. And see, for the median, they normally don't have very much melt starting around in September, but we had some melt this week, and see it spiked up a couple of days here, about 3 days, and one of those days it went up to about 8%. But look at the melting. Look at the changes this year. It's been awful. And there have been lots of articles written about the melting. Because it rained. It rained over the interior for the first time, I think, ever, that they've been measuring the rain there. So now we'll go through Climate Reanalyzer. Here are the maximum temperatures for today. And we can see the air temperature right over the North Pole and down towards Canada is around freezing or a little below. Now for the ice to freeze, the sea surface temperature has to be below freezing, about 2 degrees below freezing. So air temperature and sea surface temperature are different. So you can have air that's a little bit below freezing, but the ice can still be melting, because we have melting from underneath as well. Here is our 2-meter temperature anomaly. Now we can see Russia's coming back into the brown up here. And here's Novaya Zemlya. Here's Greenland. See, it's in the blue, so that's colder than normal. So we see all this blue air, colder than normal, over the Arctic basin. Now we've got brown coming up in Canada. So here's the global view. Now look in the Antarctic. See, that's much higher than normal. That's right under the ozone hole. This directly correlates to where the ozone hole is, the temperatures there. So overall, the temperature of the world has gone down a tiny bit. We're 0.2 C higher than normal. The northern hemisphere is up 0.6 C. The Arctic is at 0.4 C higher than normal. Tropics are up 0.4 C. Southern hemisphere is down 0.1 C, and the Antarctic is 1.1 C lower than normal. Here's precipitation and clouds. Now look at this rain on this east side of Greenland and over Iceland. We've got rain here next to Norway, coming up to Svalbard and up here in this Fram Strait. And look at all this rain up here in northern Russia and in the Kara Sea, and also up here in the Laptev Sea. Rain over here in the Beaufort Sea. And next, this is the pink is a rain-snow mix, and then the blue is snow. So the rain and the rain-snow mix, you know, that'll definitely melt the sea ice. And if the rain is on land, where you've got that permafrost, it melts or thaws out the permafrost. See, you've got rain in Alaska, there's lots of permafrost. You've got rain here in Canada, there, you know, which is good because it'll help with the fires, but it'll also thaw out that permafrost. Here's our next big system in the Atlantic, Larry. It's packing a punch, so we'll see what it does. The models I've seen, as it comes in, it makes a right turn, kind of a right angle, as before it hits the east coast here, and it just barely clips this little bit of Canada there. That's the models I've seen. Here's the jet stream. We have a low set up here over the Chukchi Sea, 992. So that's getting low. We have a high set up here over the North Pole. That's 1025. That's millibars. Look at the broken. The jet stream broke this year. And it's not going back, I don't think. We saw sea ice and snow cover. Now, sea surface temperature anomaly. I watched this really close. This is as of yesterday, and where you see the 0 means that it's not above normal. Then you see the browns, the tans and browns going up into the red. Like this dark red is about 4C higher than normal. The bright red is 5C. This pinky white is about 6C higher than normal. And so up here in the Arctic, see here in the Kara Sea, where it's so radioactive, we've got the reds and the browns there. Here in the Laptev Sea, we've got browns. Now, to pay attention, there's a little bit of blue here on the coastline, the Siberia coastline, and that on NASA Worldview, there's a little bit of refreeze that happened right there, it looked like. Now we're seeing browns come in around Svalbard. Look at all this red around Greenland. And we've got browns coming up in the Baffin Bay. We've got reds and browns in the Hudson Bay. And see all of these reds and browns worldwide. And we've got our red spot in the Pacific. We've got reds here in the Okhotsk Sea and around Kamchatka, all around this Kamchatka Peninsula. And then that comes across the Pacific. Worldwide, we're up 0.5 C higher than normal. Northern Hemisphere and North Pacific are both up 0.8 C. The North Atlantic is up 1 C, higher than normal. Southern Hemisphere is up 0.2 C, and Equatorial Pacific is in balance. So when you see the sea surface temperatures like this, you know, it's just not good. And the methane could blow just any time, and it could be blowing. It could be blowing up here at Komsomolets. I mean, it is. It's obviously percolating constantly in that one spot. But, you know, it's not the big blowout like what they're saying. But whatever. It adds up. It all adds up. Now we'll look at NASA Worldview. It's really cloudy up here today. Hard to see much of anything. This is the sea ice concentration layer, so we can see the outline. And if I turn on the blue marble layer, it'll block out the clouds, so we can see the ice here. Right up here, see a little bit of ice here. We had a little tiny bit of refreeze. Not much, it's just like a little skim. This is between the New Siberian Islands and Siberia here. All that's open. Now here's the hole in the Beaufort Sea, and this ice, it might as well not be there because this sea, it's deteriorating so fast. And we can see in the interior how it's deteriorating, coming apart, holes forming. Here's the North Pole, and here we've got the ice around Severnaya Zemlya. Here's Franz Josef Land, it's clear. Here's Svalbard, it's clear. So this eastern edge has really come down this week. Let's see, this east side of Greenland is clear. Baffin Bay is clear. A lot of these tributaries are just totally open. And you can't really tell that when you're just looking through the clouds. So the thickest part and most concentrated is along this Canadian coastline, and then the little ear that goes up just by the North Pole, that little ear there. So now I'll click through and you can see what happened this week. So let's go back. We've got to go back to August, and we'll go to the 29th was our show last week. So here we were last Sunday. So we'll just click through. So we still had a lot of ice here in the Beaufort Sea, but look at, just watch how this comes apart this week. Here we go. Watch. And look at the change from yesterday to today. I mean, it really, and that's because of the rain and the storm that's up there right now. Look, here yesterday, now watch, a lot of this aqua, well, not aqua, yeah, aqua, and the green, it just goes away. Watch. See? It's almost nothing. That might as well not be there. So there's that. So we'll see what we can see here. Here's Greenland. Now this is cloud covered. See. Here's the nearest strait. That's a pretty good view. See, that's open. See? There's a cloud over that. Here's the Lincoln Sea. This is, there's a little tiny bit of thicker ice kind of piling up on this coastline. But, see, this is the hole. Oops. This is the hole that we see. Let's go back a day. See what we can see. Here we were a couple of days ago. See? Let's go back to today, just to get a feel for it. Now, here's this eastern edge. You can see how that's coming apart. Here's Franz Josef Land. So this eastern edge is really retreating. And it goes up. Here's a storm system. Here's Severny Zemlya. Here's Komsomolets. This is the area with the methane billowing. Here's the Kara Sea. This is our radioactive area. Here's Novaya Zemlya. So they're talking this whole east coast of Novaya Zemlya. I'm thinking the whole Kara Sea. And north, probably. And west, and they were even showing down here by Svalbard. See? Clouds. Now, this is interesting. Look at this cut and paste. These are different satellite images. They come in at different times and then are put, they don't always match up. So here's our Beaufort Sea. Look at this. So they're calling this ice extent, and look at that. This is ice. Got some clouds here. See the pieces? See the pieces. So there's our storm. Now here's where it's coming away from this. See the big hole there? Coming away from the coastline. Now let's look here. See? You can see through the clouds where it's not very thick. That's open water. That's a lot of open water there. See? Here too. Here. Here. See? See? Look at all that open water. Look at that. Here's the 80-degree north latitude line. Then we're going in towards the North Pole. Look at all. Look. This is really broken up. Look. Okay, this is a good view. See? That's at 88. There's some open water there. Now see the black dot? This is when the sun starts going down. We can't see starting from the North Pole. That's where it's starting to get dark. And this black area will get bigger and bigger as we go forward. See, here's Greenland. Now, let's go back. Now there's a thicker area. See, there's a ridge of ice right here. And then it's right along here, where it's the thickest and most concentrated, and along up there. And then it like drops off. See the difference? Then it drops off into this. Look at all the open water. I mean, we're looking through clouds, but you can see this is really a lot of openness. Let's go back. Here we go. See? So that's the Beaufort Sea. There's so many clouds at this time of year it's hard to see much. But that's what we've got. I'm going to forego looking at the Antarctic today simply because this show is going to be way too long. And I think I'll just briefly go over some earthquakes. Here's what we've got right now. It's still rocking. Here in the South Atlantic, we've got 326 worldwide right now. Let's see what we had this week. I'll just show you. 7 days, all magnitudes. Let's see. We had one right up here in the Baffin Bay. This was a 4.4. That came in yesterday. We had a lot of movement on these plate lines. The South Atlantic is still moving, but look all the way down the Atlantic. Look out here in the Pacific, and all of these up and around. Now I did want to show something that's got my interest. This started up yesterday up here in the little armpit at Yakutia, or Yakutat. Why did I say Yakutia? We've got 47 right here. Now there were 62 earlier today. They had a 4. It's off the map now. There was a 4.1 up here, but this is swarming up here. Let's look at 7 days here. 85. So 85 here, and or 90. It mainly started yesterday. So there's that. See, this is the top end of where the Juan de Fuca plate comes up. So when we see this shaking, see, that's directly up. Then that, and we've had movement on the Juan de Fuca plate this week. See, we've had 4.0, 4.4, 3.0, and then these at the base of it. Look all along California, and then we've got movement at the Cocos plate, 4.8. So these are all connected. So to see this, I'm thinking that something big is going to be shaking down here soon. We had some large earthquakes here in the Sea of O coast, 5.2, 5.8. We had here in Russia a 5.0 and a 4.3 at Severomutsk, however you say that. Just, you can see. We've got massive movement. Oh, let's look at West Texas. Look at this. Texas had 58 this week. Right here, mainly. Look. Here's a new one. 4.4. Here's a 4.1, so 2 in the interior of Mexico there. Look at all of this on the west coast. If you just do like this area from just California and Nevada, look, 1,039 just this week. And it's part of Utah. We had some movement up here in northeast Nevada, up by Wells. There were 10 here. 4.7. That was the biggest one. That came in on the 31st, and it set off this other movement. Just east of Elko. We had a lot of movement. Look up here around Reno, Pyramid Lake, and just all around. So time is short. The end is near. And to finish up the show, I'd like to bring our focus back to the spiritual by reading out of the Bible. I do these shows because I do believe that the end is near, and we can see the evidence of it with the earthquakes and the weather and the methane and sea ice melting. This has all been prophesied of, and this is, I want people to know where we're at. We're close to the end. And whatever physical preparations you make, most importantly, beyond that, and first and foremost, you need to make spiritual preparation. Are you ready? Are you ready for the end? Are you ready? If this was your last day, would you be ready? So tonight we're reading out of James, and James was the brother of Jesus. He was the next one born of Mary after Jesus. James chapter 2. My brethren, have not the faith of our Lord Jesus Christ, the Lord of glory, with respect of persons. For if there come unto you your assembly a man with a gold ring and goodly apparel, and there come in also a poor man in vile raiment, and ye have respect to him that weareth the gay clothing, and say unto him, Sit thou here in a good place, and say to the poor, Stand thou there, or sit here under my footstool. Are ye not then partial in yourselves, and are become judges of evil thoughts? Hearken, my beloved brethren, hath not God chosen the poor of this world rich in faith, and heirs of the kingdom which he hath promised to them that love him? But ye have despised the poor. Do not rich men oppress you, and draw you before the judgment seats? Do not they blaspheme that worthy name by the which ye are called? If ye fulfill the royal law according to the Scripture, Thou shalt love thy neighbor as thyself, ye do well. But if ye have respect to persons, ye commit sin, and are convinced of the law as transgressors. For whosoever shall keep the whole law, and yet offend in one point, he is guilty of all. For he that said, Do not commit adultery, said also, Do not kill. Now if thou commit no adultery, yet if thou kill, thou art become a transgressor of the law. So speak ye, and so do, as they that shall be judged by the law of liberty. For he shall have judgment without mercy that hath shewed no mercy, and mercy rejoiceth against judgment. What doth it profit, my brethren, though a man say he hath faith, and have not works? Can faith save him? If a brother or sister be naked and destitute of daily food, and one of you say unto them, Depart in peace, be ye warmed and filled, notwithstanding ye give them not those things which are needful to the body, what doth it profit? Even so, faith, if it hath not works, is dead, being alone. Yea, a man may say, Thou hast faith, and I have works. Shew me thy faith without thy works, and I will shew thee my faith by my works. Thou believest that there is one God, thou dost well. The devils also believe and tremble. But wilt thou know, O vain man, that faith without works is dead? Was not Abraham our father justified by works, when he had offered Isaac his son upon the altar? Seest thou how faith wrought with his works, and by works was faith made perfect? And the scripture was filled, which saith, Abraham believed God, and it was imputed unto him for righteousness, and he was called the friend of God. Ye see then how that by works a man is justified, and not by faith alone. Likewise also was not Rahab the harlot justified by works, when she had received the messengers, and had sent them out another way. For as the body without the spirit is dead, so faith without works is dead also. James chapter 2. So as we help others along the way, that helps us, We need to help others. We need to love one another. We need to lift each other up in these end times, in these dark times. Support each other and love each other rather than tear each other down and tear them apart. So I love you all. I hope you have a good week. And if you haven't given your life to Jesus Christ, I recommend you do it before it's too late. He's coming. He's coming soon. And will you be ready? And until next time, I'm praying for you. God bless you. Go in peace, and I will talk to you soon. Good night.